Okay, so now that we know how to write a complex number polar form, what we're going to go over is multiplying two complex numbers together in polar form. So we have to have two complex numbers. So the first one we'll name z of 1, and the second one we'll name z of 2. And so in rectangular form, it would be called a plus bi, but we're going to write it down in complex numbers polar form, which will be r of 1 cis theta of 1. And I'm putting the subscripts of 1 there because it goes with the first complex number. And do the same thing. Here's our second complex number. Okay, remember, its rectangular form would be a plus bi. However, we're going to write it in polar form. Now, if I wanted to multiply these two complex numbers together, okay, that would be the same as saying what I want to do is this, r of 1 cis theta 1 times r of 2 cis theta of 2, which would be the same as, if I wrote it out, r1 cosine theta 1 plus r1 sine theta 1I times r2 cosine theta of 2 plus r2 sine theta of 2I, multiplying that together. And what that will multiply to be is going to be, you multiply the r's together, so r1 times r of 2 cis, and then you actually add the two thetas together. And so if you have to multiply two complex numbers together in polar form, you multiply the r's together and you add the thetas, and then that is your product. So although I just gave you the formula here, we can actually prove this, okay? And the reason that we can prove this is because you know about your addition properties of trigonometry, your formulas, cosine of alpha plus beta and sine of alpha plus beta. Now, you are not going to be held responsible for showing the proof, but I just wanted to give you the proof right now so that when you are using this formula, okay, multiplying two complex numbers together in polar form, it's not just like it came out of nowhere. It's from this proof that involves using your trigonometry addition formulas of cosine and sine. So the proof, okay, we take this line right here, which is multiplying two complex numbers together. And what we're going to do is we're going to expand this. If we FOIL this statement right here, so that's going to be r1 times r2 cosine theta 1 cosine theta 2. Now the outers, if we multiply this together, that's going to be plus r1 r2 cosine theta 1 sine theta 2I. And then if we do the inners, that's going to be plus r1 r2 sine theta 1I cosine theta 2. And then the product of the last, I'm running out of room here, so I'll write the fourth term here, plus r1 r2 sine theta 1I sine theta 2I. And so now, the first thing that we could do here is, notice all four of these terms have a common factor of r1, r2. So I can factor that out of all of these terms. Also, notice this fourth term here, I have an I times an I here. Now I times I, that's going to be I squared, and I squared is equal to -1. So this actually simplifies, this fourth term actually simplifies to, I'll write it right up here, minus R1, R2, sine theta 1, sine theta 2. Okay, so we factor out the R1, R2, we get cosine theta 1, cosine theta 2, plus cosine theta 1 sine theta 2i, plus sine theta 1i cosine theta 2 minus sine theta 1 sine theta 2. Now, what I'm going to do is I'm just going to move terms next to each other. So the first thing I'm going to do is I'm going to put this fourth term here. I'm just going to move it so that it's next to this term. And if you notice, this term and this term have a common factor of I. So I'm going to put them next to each other. And then what I'm going to do is I'm going to factor out the I there. So this is R1, R2 times cosine of the first angle, cosine of that second angle. Now I'm going to rewrite this term next to it. Minus sine of angle 1, sine of the second angle, theta 2. Plus, now if you look at this, both of these terms share a factor of I. So I'm going to factor out the I. That's going to be cosine theta 1 sine theta 2 plus sine theta 1 cosine theta 2. And so now, if we look at this, that right there, okay, that right there is the cosine of adding two angles together. And this right here is the expansion of the sum of sine. So this is the expansion of the sum of cosine. This is the expansion of the sum of sine. So if we put those in, what we really have is R1, R2. This is cosine of theta 1 plus theta 2 plus, but we don't usually write the I on the left. We usually write on the right-hand side here. So plus sine theta 1 plus theta 2 times I. And so, if we were to now multiply this out, now look, this is A, this is B right here. So A would be R1, R2 cosine theta 1 plus theta 2 plus R1, R2 sine of theta 1 plus theta 2 I, which would be the same as just saying R1, R2 cis theta 1 plus theta 2 I. So now we'll do an example problem. We're going to express the product in polar and rectangular form. So we have a complex number times another complex number. And the first thing we should do is get the product in polar form. So you multiply the r's together. So it's going to be 4 times 12, which is 48, cis, and then 60 plus 34 is 94 degrees. So this is your new complex number. 48 cis 94 degrees. So since that's between 0 and 360 degrees, I wouldn't really try and write its coterminal angle, right? We have 48 cis 94 degrees. But now we also need to write it in its rectangular form. So we have to go back to the A plus BI. So that's what rectangular form is, A plus BI. But don't forget, A is just R cosine theta, and B is just R sine theta. And so this is just going to be 48 cosine 94 degrees plus 48 sine of 94 degrees I. So now just use your calculator. Okay, make sure you're in degree mode and just type in 48 cosine of 94 degrees. Now 94 degrees, that is in quadrant 2. Therefore, we should expect a negative number here. And we get negative 3.348. So negative 3.348 plus, and we know that 94 degrees, right? We see it here, 94 degrees. That's going to be in quadrant 2. So we know the y coordinate, okay? The b is going to end up being positive. So 48 times sine of 94 gives us 47.883. So plus 47.883I. So this is the rectangular form of the product, and this is the polar form of the product.